The story of human origins is both an ancient mystery and a cutting-edge scientific endeavor. Among the most intriguing theories is that of Mitochondrial Eve, the woman believed to be the matrilineal common ancestor of all living humans. Her genetic fingerprint ties us together across continents and millennia, offering a window into the origins of our species. Complementing this genetic narrative is the discovery of the Homo 1 skull in Ethiopia, which has been interpreted by some as a representative of this critical evolutionary period. Together, these lines of evidence, the genetic and the fossil, provide a fascinating glimpse into the dawn of Homo sapiens. The term Mitochondrial Eve may evoke biblical connotations, but it is a thoroughly scientific concept rooted in genetics. This Eve is not the first woman, nor is she the only woman of her time. Instead, she represents the most recent common matrilineal ancestor of all living humans, traced through mitochondrial DNA. This genetic material, passed exclusively from mothers to their offspring, provides a direct lineage unaffected by the recombination that occurs in nuclear DNA. Studies of mitochondrial DNA suggest that Mitochondrial Eve lived around 200,000 years ago in East Africa. Mitochondrial Eve's existence is inferred through the concept of the molecular clock, a tool that estimates the time of evolutionary divergence based on the rate of genetic mutations. Importantly, this does not imply that Eve was the only woman of her time. Instead, she represents a genealogical bottleneck, a point where her mitochondrial DNA lineage outlasted all others. This research has been instrumental in the out-of-Africa hypothesis, which posits that modern humans originated in East Africa before dispersing to populate the rest of the world. Mitochondrial Eve's descendants carried her genetic legacy out of Africa, spreading it across the globe. In 1967, a team led by renowned paleoanthropologist Richard Leakey made a groundbreaking discovery along the Omo River in southern Ethiopia. The Omo Kibish Formation had long piqued paleontologists' interest due to its abundance of ancient sedimentary layers that record millions of years of Earth's history. During their excavations, Leakey's team discovered two hominid fossils, which they named Homo 1 and Homo 2. These fossils would go on to be some of the most important pieces of evidence for the study of early modern humans. Homo 1 was discovered in situ, which means it was found within its original sedimentary context. Some researchers have speculated that the fossil was intentionally buried due to its location and preservation. The idea that Homo 1 was purposefully buried is contentious. While the in situ discovery suggests intentional placement, the evidence is not conclusive. Meanwhile, Homo 2 was found on the surface without any other archaeology associated with it, except for some curiously polished surfaces. Homo 1 was found buried a few feet below the surface, in what likely was a deliberate burial, because much of the skeleton was found with the skull. If this is the case, then it is highly significant, because no other human burials are known before 120,000 years ago. Furthermore, Homo 1 was found in association with bones of wild buffalo. Cattle are a very ancient part of the local culture, and being buried with cattle bones is a long-held tradition. This is an interesting point we will address later in the video. Homo 1 is one of the oldest known fossils of anatomically modern Homo sapiens. The skull's rounded cranium, small brow ridges and high forehead are hallmarks of modern humans, distinguishing it from earlier hominins. Its discovery marked a critical moment in paleoanthropology, cementing Ethiopia's place as a cradle of human evolution. The fossil was also recently determined to be most likely a female, placing it within the time frame of the genetic data for Mitochondrial Eve. The environment of Ethiopia would have been abundant with resources such as wild plants, animals, and freshwater sources like the nearby Omo River. Life during this time would have been physically demanding and dangerous. Large predators, such as lions and hyenas, roamed the landscape, and competition for resources with other hominid groups was probably fierce. The fossil evidence supporting the timeline of Mitochondrial Eve comes in part from the Homo 1 skull. But could Homo 1 represent Mitochondrial Eve herself, or at least someone from her time period? While it's impossible to link specific fossils to individual ancestors, Homo 1 provides a tangible connection to the time and place where our species first emerged. Most researchers now believe that the skull belonged to a female, further fueling the association with Mitochondrial Eve. Initially dated to about 37,000 years ago, the skull was later dated to 130,000 years ago and reconstructed as a robust male. But more recent techniques have revised its age to 195,000 years, but the most recent date is an astonishing 233,000 years or more. Yet, this dating is a proverbial rabbit hole, because the dating is based on the sedimentary layer that the fossil was found, and if this was a deliberate burial, then the fossil could be as little as 50,000 years old based on the fauna found associated with it. Additionally, Homo 1's face is relatively flat compared, but some researchers suggest that this could also be a product of reconstruction choices. One major point of contention is the interpretation of Homo 1's brow ridge. The brow ridge is notably reduced, consistent with modern Homo sapiens. Critics argue, however, that this reduction might be due to female dimorphism. In fact, a recent paper presented strong evidence, based on features of the pelvis, that this skull was from a robust female rather than a gracile male. According to the most recent study, Homo 1 has features that suggest this skeleton belonged to a tall, robust, childbearing age, early modern human woman. Her leg bones indicate a height of up to 6 feet tall, with a slender but muscular build. The pelvis has been shown to most likely be female, and the some features of the mandible and muscle attachments on the back of the skull are also suggestive of a gracile female specimen. In Ethiopia's Omo Valley and surrounding regions, tribes known for their tall stature are primarily from the Nilo-Saharan group, specifically the Nyangatom tribe and South Sudanese-related groups such as the Dinka and Nuer. Nilo-Saharan-speaking peoples, including the Dinka and Nuer, are known for their extraordinary height. According to historical measurements, Dinka women have an average height of 6 feet tall. This new finding has huge implications for the reconstruction of the face, which was assumed to be a male back in 1982 when it was reconstructed using clay. Astonishingly, over 40 years later, there has not been an updated reconstruction, no 3D analysis of the jaw or the teeth or the brain case. Nothing. In fact, the skull has been hidden in a storage room at the Ethiopian Museum for over 40 years, with no new analysis since the 1980s. The mandible, or lower jaw, differs significantly between males and females due to sexual dimorphism. Males' mandibular angles are typically closer to 90 degrees, resulting in a square-shaped jawline that is often exaggerated by stronger jaw muscles. Meanwhile, females generally have a rounder jawline due to a more obtuse angle, closer to 120 degrees, contributing to a more gracile facial appearance. The mandibular angle, size and robustness, and chin prominence are all important indicators of sex. But as shown, when the Homo 1 and Homo 2 skulls are overlaid, they show an almost identical profile, except for the occipital base. So, the only major differences between the two are the size of the brow ridges, overall robustness, and the size of the occipital, and some differences can be explained due to natural deformation. The sides of Homo 1 appear to be flattened, and it is described as being slab-sided. A slab-sided appearance in fossil skulls is sometimes caused by post-burial deformation rather than being an inherent feature of the individual's anatomy. This phenomenon is common in paleoanthropology, where fossilization and geological forces frequently change the shape of skeletal remains. Mistaking deformation for an anatomical trait can result in incorrect reconstructions of fossil morphology and evolutionary relationships. To understand Mitochondrial Eve and her contemporaries, we must imagine the world as it was 200,000 years ago. Africa was a land of fluctuating climates, shifting between arid deserts and lush savannas due to cyclical changes in Earth's orbit. These environmental pressures likely played a key role in shaping early Homo sapiens, favoring adaptability and innovation. Eve's world was populated by small, mobile groups of hunter-gatherers who relied on their wits and social cohesion to survive. These early humans used simple stone tools, hunted game, and gathered plants. While their material culture may seem rudimentary compared to later societies, they possess the seeds of behaviors that would define our species, including symbolic thought, complex language, and social structures. Are these specimens really our ancestors? We cannot know without DNA. Did they give rise to our East African ancestors? Maybe. Or are they an offshoot of the main line, a group that was on its way to becoming a distinct species before dying out? Our experience in prehistoric Africa, however it unfolded, was not simple. Human lineages are constantly splitting, dying and rejoining, but it is still unclear exactly when we became human. Evolution does not always provide clear distinctions between different forms of a species. Genetic studies suggest that Mitochondrial Eve's descendants experienced a population bottleneck during this period, reducing their numbers to perhaps just a few thousand individuals. This genetic choke point may have been triggered by environmental challenges, such as severe droughts, or by competition with other hominins. Despite these challenges, Homo sapiens endured, eventually expanding and diversifying. One of the great challenges in human evolution is bridging the gap between genetic and fossil evidence. While mitochondrial DNA provides a clear timeline for Mitochondrial Eve, fossils such as Homo 1 offer a physical record of our ancestors' morphology and behavior. The two lines of evidence align remarkably well, reinforcing the idea that modern humans originated in Africa over 200,000 years ago. Nevertheless, questions remain. The understanding of early human behavior often hinges on more than the physical structures of our ancestors. It includes insights into their cultural and symbolic lives. The Herto and Homo 2 skulls provide compelling evidence of mortuary practices, hinting at the symbolic and ritualistic behavior of early Homo sapiens and their close relatives. These practices underscore a level of cognitive sophistication and emotional depth that defines our species. The Herto fossils, discovered near the Middle Awash region of Ethiopia, date to approximately 157,000 years ago, making them among the earliest examples of anatomically modern Homo sapiens. These fossils include adult and juvenile skulls, with distinctive evidence of deliberate modification. One adult skull, in particular, has been extensively studied for marks that suggest symbolic treatment. Several Herto skulls exhibit cut marks consistent with defleshing. These marks are concentrated around the base of the skull and the face, suggesting the removal of soft tissue after death. Such treatment was unlikely to be a simple practical process, but appears to reflect ritualized handling of the dead. The care with which these remains were treated indicates that early Homo sapiens likely engaged in symbolic practices surrounding death. The placement and preservation of the Herto skulls suggests that they were not buried in the ground but likely displayed or used in a ceremonial context. This behavior aligns with the early expressions of symbolic thought and social cohesion, including the Homo 2 skull. These two skulls have a very similar profile, especially the occipital region, in contrast to the Homo 1 skull. The treatment of the Herto skulls provides one of the earliest examples of mortuary behavior in Homo sapiens, highlighting the emergence of symbolic practices and perhaps even early forms of spiritual belief. The Herto skulls demonstrate that the treatment of the dead was not unique to modern humans, but likely evolved gradually over hundreds of thousands of years. These practices reveal significant aspects of early hominin cognition. However, one of the most striking features of the Herto skulls, dating to approximately 160,000 years ago, is the evidence of intentional polishing on their surfaces. Homo 2, also a surface find, also has signs of polishing, indicating this could be a very ancient tradition. This polishing is significant because it indicates deliberate post-mortem treatment of human remains, suggesting an early form of symbolic behavior among anatomically modern Homo sapiens. Indeed, the adult Herto skull, particularly the cranium, exhibits clear signs of polishing. This is visible as a smooth, glossy surface in areas that would not naturally develop such a sheen from burial or environmental factors. The patterns of polishing are not random. They are concentrated in prominent areas of the skull, such as the brow ridges and forehead, which might have been emphasized for aesthetic or symbolic reasons. The polishing of the Herto skulls provides an extraordinary glimpse into the minds and behaviors of early Homo sapiens. It represents one of the earliest known examples of post-mortem modification for symbolic purposes. The evidence supports the idea that by 160,000 years ago, humans were not only anatomically modern, but also culturally and cognitively sophisticated, capable of complex symbolic thought and practices. By connecting the dots between fossils like Omo and Herto, we see a continuum of symbolic behavior that bridges the archaic and modern worlds. Together, these discoveries paint a vivid picture of humanity's earliest steps toward understanding and commemorating the mysteries of life and death. Nevertheless, the story of Mitochondrial Eve is more than a scientific curiosity. It has profound implications for how we view ourselves and our shared humanity. Her existence reminds us that despite our superficial differences, all humans are connected by a single, unbroken chain of mothers stretching back over 200,000 years. The stories of Mitochondrial Eve and the Omo 1 skull offer a compelling narrative of human origins. One represents our genetic inheritance, a silent but powerful record encoded in the DNA of every living person. The other is a tangible relic, a physical reminder of the people who walked the earth tens of thousands of years ago. As science continues to uncover the secrets of our past, the legacy of Mitochondrial Eve and Omo 1 will remain central to our understanding of humanity's remarkable journey. Omo 1 was more than just a fossil. She lived and breathed in a world very different from ours. And with that tantalizing statement, we leave you to ponder the mysteries of our shared human history. And before you go, please share, comment, and check out the other videos on our channel. Thank you and take care.